Hello and welcome. In this small video lecture, we are going to address this owl representation problem, which states a vegetarian is any animal that eats only things that are not animals or parts of animals. Now you can see this is a kind of bit involved statement, and we need to have a closer look at it and try to disintegrate into different parts so that we can represent the thing correctly. Right. So apparently to say, so this is a case of equivalent class representation. We are defining this vegetarian class here using equivalent class representation, right? And this equivalence, you have this vegetarian to be C1, and the other part is any animal. So in the sense, animal that eats only things that are not animals or parts of animals. So this is our C2, right? So the entire concept expression, so this will be our plan. The entire concept expression is involving C1 and C2, and this C is a equivalent class uh, expression, right? Now C1 becomes to be our vegetarian, right? So let us try to build this from this particular structure. So equivalent classes, then vegetarian, right? And then we will be having C2, right? Now what is our C2? C2 is basically uh, it should be one animal, right? And also it should be something that eats only things that, so remaining part, right? So this C2 can be disintegrated into two parts. One is animal, so this will be our C2A, and the other thing eats the things that eats only things that are not animal or parts of animal. So this will be our C2B, right? So here disintegrating C2, we are disintegrating C2 as C2A and C2B. C2A and C2B, right? So it will be an intersection. So this will be an intersection, right? So C2 is an intersection of C2A and C2B. So it's right, object intersection of two things, right? C2A is animal, right? Now it will be followed by C2B, right? Now how do we write C2B? So C2B is basically will be involving all values from restriction, and the restriction would be on each. So we'll be having a structure like each to represent C2B, right? And what would be the two classes inside it, inside this restriction? So now we are disintegrating this class of C2B into two parts. One is things that are not animal. So this is our C2B prime, and the other thing is parts of animal, which is C2B double prime. C2B double prime. So we'll be having two class expressions, C2B prime and C2B double prime, and they will be conjoined with uh, uh, something called intersection, right? So things that does not eat animal and as well as parts of animal. So this is the sense that we are trying to represent, right? So C2B will be representing as object all values. Object all values from, right? And the first thing that we need to have is the property which is eat, right? Or eats. We have written eats, let us ready to be eaten, right? Now this C to B, what it is really? It is negation of animal, right? So for that we need to say and we need to and what is C to B prime double prime? C to B double prime is basically is some a thing that has got at least, that is part of, at least that has got at least one relation having label to be part of, and the value that it will be having, this relation will be having, will be belonging to the animal class. So in that sense we will be representing that as there exists part of animal, and we put a negation before it, right? Because we have a not here, not animals, not parts of animals, right? So if we now try to represent this, we will be picking up this part, right? We will be representing this as object intersection, object intersection of, right? An intersection of two things. So the first thing is object complement of animal, object complement of animal, right? And the other thing is object complement of, and this object complement of will be over this some values from part of animal, right? So we'll be having object complement of, and inside that we'll be having object some values, object some values from and what would be the property? The property will be part of, and the class will be animal, right? We close this, we close the complement, we close the intersection, close the all values from, we close the other intersection and equivalent class. So this is the corresponding functional style owl representation of this particular statement, and you can see that if we have a complex statement like this, how we can look at it in a piecemeal manner and try to connect the pieces and to come up with this representation, this complex representation. Now let us focus on to represent this in the corresponding description logic form, right? So the description logic form for this would be, so vegetarian class is equivalent to animal intersection of, for all its not of animal and intersection not of there exists part of animal, right? And actually you can have another equivalent form of this, which is animal and for all its not of animal and for all its not of part of animal. So these two expressions are equivalent with each, right? Now let us try to remodel this in first order logic language, right? So we are trying to define the FOL form for this, right? So this is how we'll be going about. So for all x, vegetarian x will both way imply animal x, right? And now let us convert this part, right? And for all t when x is t, that implies that t is not an animal. T is not an animal, and then this part, negation of part of animal, right? So negation of will be directly using there exists an animal A, right? And uh, such that t is a part of A, t is a part of A, and A is an animal. So this is the first order logic representation of this same statement. Thank you very much.